Everyone, today we are going to start our new unit, that is support reaction. For the understanding of support reaction, we have to understand about the what is the structure, what is structural system, and in that what is beam. So today in this lecture we are going to understand about the beam and its support, and after that what reaction developed by the support. So first of all, let me clear our structural system is consists of major four elements. First one is slab, and the function of that slab is to cover the whole building. After that, beam. Beam is a horizontal element, is provide for the supporting of slab. Third one, column. It's a vertical member of the structure, and the function of that column is carry the load transfer from the beam systematically. And the fourth one, that is footing. Footing is provided in the base of the building, and the function of that footing, load coming from the column must be diverted or transferred to the soil for the stabilize whole the structure. So in that case all the elements are flexural member, and today we are going to study about one of them, beam as a flexural member. So what is beam? Beam is a structural member subjected to transfer loads. Its length is large in comparison with the cross-sectional dimension that we know. Beam are used in residential building, multi-story complex, industrial buildings, bridges, etc. Load from the slab, floor, walls, etc. transferred to the column through the beam, as we discussed. Due to loading on the beam, reactions developed at the support. This chapter deals with the different type of beams, different types of loads, and types of support and reaction occurring at the support. How much reaction at the support can be developed due to loading. So first of all, we have to understand about the types of beam. In that, measure 6 type of beam. First one is simply supported beam. Means a beam is simply rest on two support like walls. It is called as a simply supported beam. Second one is overhang beam. Means a simply supported beam is extended somewhat length, and it is overhang from this support is called overhanged beam. This is overhang at right, this is overhang at left, and this is overhang on both sides. Number 3, that is cantilever beam. Means column over here, and on another end there is no support, means totally free at this end. This is our simply supported beam, means this to our wall and this is our beam is simply rest on this support. This is cantilever, means somewhere over here it is fixed and the extended portion there is a no support at the end. This is again cantilever beam. It's a bridge deck and it is from here to center of this point is free. Again from here it is fixed and at center of beam it free. So it is called cantilever. This is our overhang beam, means from this support it is extended up to somewhat length. So it is overhanged beam. Now another beam, that is fixed beam, means both the ends are fixed with the columns. Continuous beam, major of the structure contains this kind of continuous beam and it is most important for us for the designing of any structure. And this one is propped cantilever, means at end of the cantilever there are some support. It's called as propped, so it is called propped cantilever beam. So measure 6 type of beam in our whole structure. Now types of loads. There are 3 types of load. First one is point load, means on the beam there are simply a point load acting on the beam. It is called point load. The load concentrated and at one point is called as point load. Unit of this point load is Newton or kilonewton. Second one is UDL, means it is a uniformly distributed load. This UDL must be generated by the wall or else from the slab. So load transfer on the beam due to wall and due to slab, it is creating UDL, means uniformly distributed load, and the unit of that load is kilonewton per meter, means throughout the length somewhat kilonewton load is thoroughly distributed. Unit of this UDL is kilonewton per meter or else Newton per meter. Third one is that is UVL, uniformly varying load. This kind of load is also known as triangle load, and this load is generated due to soil pressure or else water pressure, means it is hydrostatic force. So in this case it is a gradually increased or sometimes it is gradually decreased load. Clear? So it is also called as a triangle load. Now the most important thing, that is support. Here there are 4 type of support is there: simple support, hinge support, roller support and the fixed support. First one is simple support. This support is called as simple support, means only a wall over there and we are just putting beam on the wall. So wall is just react only a one reaction, that is vertical. So it is a simple support. There are only a vertical reaction is generated by the support. Another, that is hinge support, and this support, hinge support is producing two reaction. First one is vertical and second one is horizontal, means due to this support our beam can't be moved downward or else can't be moved leftward. So reaction is generated towards the right and here vertical reaction generated upward direction. So due to this force our resultant reaction is also there. So here beam and supports are connected by a hinge. What it Do you know what is hinge? Actually, in garden there is a seesaw. So all of you have aware about this seesaw, and that seesaw is fixed at the center of the support. That is called hinge support. Number two, our door is connected by the support, and that support is called as a hinge support. So beam can rotate about its hinge, but it can't move downward or can't move leftward. Reaction may be vertical and the horizontal, that we know. Now the important thing, that is roller support, and this roller support is generally provided at the base of the bridge deck. So all of you are aware about that. Roller support is provided at the end of the bridge deck. So that roller support also creating a one vertical reaction. Next one is fixed support. That is most important. Beam is completely fixed at the end of the wall or support or else the column. Beam cannot rotate at the ends because it is the fixed. So reaction may be vertical, horizontal, and the moment also there, like this. Here this is a fixed support, so the beam can't move downward, can't move leftward, or can't be rotated. So the reactions are there, vertical, horizontal, and moment. But due to this horizontal and vertical, resultant reaction is there. This is our roller support, and generally we are providing this support at end of the bridge deck. Also it is provided at the end of our truss. Now this is our hinge support. It only rotate over here, can't move leftward or can't move downward. Now for the understanding of how to calculate the reactions, we have to understand about the how we can calculate the moment, because all the beams are statically determinate beams, and due to that determinacy there are three conditions generated over there. First one is sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. What means of that equilibrium condition? Because we are considering that our beam is always in position of stable, means is in equilibrium, means vertically it must be stable, horizontally it must be stable, and due to rotation it must be stable. So sum of all the moments is 0, sum of the vertical forces is 0, and sum of all horizontal force must be 0. Then and then we can say that that beam is in stable position. And as an engineer, as a structure engineer, our most important role, that is our structure must be stable, means it must be in equilibrium. So for the equilibrium of the structure, for the stability of the structure, we must have to maintain that three conditions is 0 always there. So for that we must have to calculate the summation of moment due to force at any point. So for that we have to understand about how to calculate the moment at particular point. So here one of the member is there having 2 point loads at some distance. So whenever we have to calculate the moment at particular point A, what it happens? Due to 30 kilonewton force, it creating clockwise moment at A. So it is 30 into 2, and another force creating again clockwise moment, that is 20 into 3.5 at A point. So summation of all the moment at A, that is 130 kilonewton into meter. So it is most important thing for the calculation of reaction due to support. Another case, this is our UDL, and a 20 kilonewton per meter load is acting on the beam, and the length of the beam is 4 meter. Now here it is a 20 kilonewton per meter, but whenever we have to calculate the moment, it must be in kilonewton. So what is our equation of moment? Force into distance. So we have to convert this 20 kilonewton per meter UDL in the form of point load. So due to this UDL, point load always acting at the center of the beam. So it is 20 into 4. So it is converted in the point load which acting at the center. So here it is a 20 into 4, so 80, and 80 into 2 creating clockwise moment at A. So 20 into 4 into 2. So it is 160 kilonewton into meter moment at the A point. Another case, here moment at A due to 50 kilonewton, that is 50 into 4, because it is kilonewton. But here it is kilonewton per meter. So first we have to take point load at the center. So it is 30 into 3, means it is 90, and point load at the center, it is from here to here, it is 1.5. So 90 into 2 plus 2 and plus 1.5. So 90 into 5.5. So it creating the moment at A. So total sum of the moment, that is 595 kilonewton into meter. So this is just sample calculation of moment, how we can calculate the moment at particular point. So for the detailed understanding of this phenomena, we have to take a simple example for the detailed understanding. So here one example is there. Find support reaction at a beam shown in the figure. So it is a simple support, here also a simple support. So simple support always gives us one vertical reaction, that is RA, and here it is RB, and we have to finding out these two reaction RA and RB. So for that we have to take our equilibrium condition one by one. So first, here it is 8 kilonewton at the distance of 2, and here it is 4 kilonewton per meter at the 4 meter distance. So we have to convert it into point load. So it is 4 into 4, 16 kilonewton at the center of this 4 meter. So from here to here it is 2 meter. Now for that we have to take moment as a equilibrium. So what happening? Taking moment at A. So summation of moment at A is 0. Here we have to consider that anticlockwise moment is equal to clockwise moment. So what happening? Anticlockwise moment is generating due to RB. So it is RB into 8, it is anticlockwise moment, and 2 clockwise moment, that is 8 into 2 plus 4 into 4 into distance, that is 6. So here we will get the RB into 8 is equal to 16 plus 96, so total 112. So RB is equal to 4 kilonewton over here. Now the total load summation, that is sigma V is equal to 0. So RA plus RB is equal to total load. That also we can say that. So Ra is equal to total vertical load minus Rb, and here total vertical load, that is 8 plus 4 into 4. So it is 8 plus 16 minus 14. So Ra is equal to 10 kilonewton. So here there is no horizontal force, that's why we are not considering that sigma h is equal to 0. But whenever we have horizontal force is there, then we must have to take third condition, that is sigma h is equal to 0. Now another lots of examples are there for the finding out the support reaction, that we will discuss in our next lecture. Till then, just you go through the all theory portion, types of support, types of load, types of beam. These three important things are there for the calculation of reaction particular beam. Okay, thank you very much.